Okay, in this video we'll have a look at this CNC plasma cutter by Bestarc. This is the BTC500XP. It's their 11th generation version. We'll get it hooked up, do a test cut. We'll also open the cover up and have a little look inside and have a look around. Tell you my initial impressions of the machine. I also intend to turn this into a CNC plasma, so we'll give you a quick tour of some early CAD that I've drawn up and welcome your feedback. Alright, let's get into the video.
Welcome back to the workshop and welcome to this new video series on this, which is my new plasma cutter. So there's a whole range of features on this that I really like. We've got 2T, 4T cutting, there's special options for cutting wire mesh. You've got the regulator on the front here, you've got two ports on the back, one which you can tee off for the arc voltage, and another one for CNC controls and things like that. So it's a really nice, well-spec'd machine. So I'm really looking forward to this machine. However, as we like to say on this channel...
Could it be improved?
Oh, you're back, are you?
Afraid so.
Alright, let's get into the video. Okay, so let's get into the detail then. This is a 50 amp machine, but critically this is a blowback style. So that's the way you start the pilot arc. There's two main types I'm aware of. One's high frequency and one's this blowback type. Now, because, as I'm sure you guessed with the thumbnail, my plan is to CNC this, I went for the blowback style, but they're a little bit harder to find or can be more expensive. However, we'll get into the price of this and what you get for it in a minute, and you might understand why I've gone for this particular model. Alright, so some of the other features are, we've got 2T, 4T cutting. I don't think that will matter being CNC, but what it means is in 2T mode, we hold down the trigger and let go, that start, stop. In 4T, it's a bit like TIG welding. Press the trigger once, it starts, and then you press the trigger again, it stops. But some other great features are you're able to cut wire mesh because it can you can control how long the pilot comes on for, a whole load of stuff like that. Again, probably not going to be cutting a lot of wire mesh, but lots of nice features like that. There were a few other things in here as well. I just like the overall look of this machine and the features and the price. This is their 11th generation machine, so clearly with when you get into the fine detail, you can see they've learned and built up, and what I think is a really nice product here. You've got a Euro style fitting down there, and I'm going to call it the earth clamp, but I guess that might be the positive for plasma. Anyway, that's your two clamps there. I'll show you the accessories in a minute. Now we can't fire it up yet. We'll show you why. Let me show you around the back. So it comes with an air filter built in. Now I have taken, as you might expect, I've actually taken the unit apart and had a look. Yeah, there's a little filter in here, and there's a little valve drain thing. You can drain the water out, and then obviously you can hook your airline up to there. Now we'll get into detail probably a bit later, but this was really difficult to get hold of. You can't actually buy it in the UK officially. There doesn't seem to be any reseller for it. In the end, I emailed Bestarc in China, just went onto their website and said, have you got any resellers anywhere I can buy this? And it was listed about £420. And they said, yes, sure, tell you what, we'll just put you a special link to our inventory, and you can order it direct. And the only thing is, the only model they had in stock, well, they sell Euro style models for European. Now obviously in the UK, that would still leave us with the wrong plug, but at least it'd be 220. And then this US style, and I think they had an Australian style as well. So the only one I could get hold of was a US style. So it's a dual voltage 110, 220. That's okay with 220 in the UK. Does mean it's got this type of plug on it, which we'll get into more about that in a minute. And the other thing it comes with is this airline. Now all my workshop is Euro style, and this is a US spec. I couldn't quite find exactly what it was, but we'll get into what I've had to do to make that work in a minute. But if you Google something like, I think it's called Rectus Type 23, that is what is compatible with this. I don't know if you call it a 1/4 inch. I couldn't actually nail down the spec, but you will need either to take this barb fitting out, take this apart and unscrew it and screw in your own barb with a Euro on if you're living in UK or Europe, or what I've done is buy some adapters that take you from this to Euro. So in terms of all the bits you get with it, so this is what they expect you to use as your airline. And I did check, and this does fit, and then you put some hose clamps on. What you do at the other end, I don't know. I guess I think you might go to a barb, to whatever standard you're using. I didn't really fancy that, so I've hooked something up. Well, I bought something that's a bit nicer, but we'll get into that in a minute. So you get that, you get some PTFE tape, and you get the different size nozzles. I don't know what size these are, maybe they're marked on it, I don't know. Because in theory, depending on what amps you're tending to run, if you're low amps, medium or high amps, you should ideally put the larger hole for the bigger amps. I think for what I'm going to be doing, which is generally quite thin, millimetre or two at max, folding boxes and things like that, I'll be sticking with the small one I think that's currently on it. But anyway, you get those, and maybe those different colours are the different sizes. Yeah, could be. Okay, I should point out I've never done anything plasma before. The only thing I've done is watch people use them on YouTube. I've got no first-hand experience, so bear that in mind as we go through the video. This is my journey of discovery and working out how I'm going to do this. I do have a fair bit of experience with CNC machines. I built probably 4 with minor additions over many years, so that side I'm okay with, but plasma I'm very new. Anyway, that's that. We then get the torch, and this, I forget what they call it. I'll put on the screen what it's called. I thought it was a PT40, maybe PT80. I don't know. Now this has actually got like a little guard there, so that you can put it on the surface and you get the right clearance. It's important that doesn't touch, but it's also important it's not too far away. I understand. Being CNC, I need to work out how I can get that off. It seems to be quite firmly on there, but we probably don't need that. Safety trigger, but we'll have that on permanently. We'll have it CNC controlled, and then at the other end you got your Euro. I'll leave it for now because I want to keep it as clean as possible. Euro fitting goes in the front, so that's all fine. You also get, well, I'm going to call the earth clamp, but I can't remember if it's definitely earth on this type of machine. And then the other thing you get, apart from gummy bears, we'll eat those later. Yeah, nice when they put a treat in, isn't it? Is the 2 little, I guess, GX16. So you got a 2-pin and a 5-pin, already wired up. So that'll be for your arc voltage. Now, bear in mind that'll be 1-to-1, so that'll be 120, 130 volts, whatever it is, coming out of there. So be careful what you do with that. And then this is various signals, or if the arc started, stop start, I guess, things like that. I don't know yet, but it's in there, CNC control effectively. So I think they're the bits you get. You get one. Oh, okay. I guess that's a spanner for changing the tips. Okay. All right. Right, let's talk a little bit about power. Now, this is a 50 amp machine, but that's the amps coming out of the plasma. But because that's coming out at a different voltage to the mains voltage, in terms of current that's going in, that's actually a little bit less. However, they still recommend that this is connected to a 32 amp outlet. Now, in the UK, double outlets are maximum, I think, about 14 amps on. They test them 14 amps on one and 6 on the other, so a total of 20. So that's far short of 32 for one. So even if I swap this plug over for a UK plug, technically that would be pulling more current than the socket would allow. Now it'd probably blow the fuse, being a 13 amp fuse, although sometimes they take a bit more than that to blow, so maybe you get away with it, but feels a bit wrong. If it says connect to a 32 amp and we're connecting to a 20 amp socket, it doesn't feel right. Now what actually comes with the machine is, there we are, I don't know if you can see that, 2.5 square millimeter cable. So typically in the UK, typically that would be what would be on your ring main, so that's what you would have going to those sockets, which are rated about 20 amps. Now this is not enclosed, it is in free environment, so maybe it'd take a few more amps than that, but it's not really 32, is it? When I open the machine up, it does have the 2.5 millimeter conductors. So I did ask the company at the time. Obviously I knew the plug wasn't going to fit. Will I invalidate the warranty if I cut this off and put a UK plug on? Again, I hadn't looked into the amps at that point. and that's absolutely fine. So that was my original plan, but I don't know where to go with this, because maybe you're only using it for a minute or two at a time, you're cutting a few shapes out, yeah, it would work, it would be okay, and it probably wouldn't blow the fuse, I don't know. But you know, technically if you look at the numbers, they're asking you to connect it to a 38 2-amp socket. Now that would mean technically connecting it to what's kind of colloquially called a commando socket, you know, one a bit like this. Now I don't have that in the workshop, and I don't have enough free spaces on the consumer unit to wire one in, so I'd have to get an electrician to add an additional consumer unit and then run a cable to the workshop, which is quite a distance away. It's on the other side of the house. Doable, you know, so I could bring a commando socket in and then put a commando socket in the end of this, or more likely upgrade this to a 6mm flex and rewire the whole thing, because it's only got like spade terminals onto a switch when you go inside here. So basically redo this with a commando 6mm square, and then I think I'd feel safe. Because if you look at it depends if they're in a wall, if they're insulated, buried, but let's put some nominal current figures that I could find anyway. 2.5, which is what this is up to 18. Well, that's short of 32, isn't it? 6mm square is 36 amps, and 10 43. So really you'd want somewhere maybe about 6, which is obviously bigger than this. So I'm still looking into that. I think that's the safe way to go. But what I might do for initially is, just for testing, just to get it working, is put the plug on here, turn the amps right down to the minimum. You know, if it blows a fuse, it blows a fuse, but maybe I can get cutting, at least manually, make sure it's all working, and then take it from there. Then the second thing worth talking about is this fitting here. Obviously this is meant to be shipped to the US, so that's this Type 23 Rectus type fitting. Maybe it's got a different name over there, I don't know. It's certainly not a Euro. So I've just been down to my local pneumatic shop. Luckily, I didn't know they were there, but there's like an industrial one pretty close to me. And I basically took this in and took the airline with the Euro fitting on, said I want to go from here to here. And I needed a bit of distance anyway, because my extension coil wouldn't reach between the airline and the plasma, they're a bit too far away. And they hooked me up with this. So that goes on there, and that ends in a Euro fitting. But as you can see, they've had to jump with a couple of adapters, particularly on that end, and hopefully you can see that engraved on there. That is called it's probably a brand name, Rectus Type 23. So NW 5.5, made in Germany, and that goes on there. It feels heavy, feels quality, and this came to £85. What can you do, eh? What can you do? So bear that in mind. Maybe there's another way where you can just change this out if you've got, you know, if you're happy to do that inside there directly for a Euro fitting. Anyway, bear that in mind. So what my plan is, at least initially, is to use this cable here. So this is 2.5. So I got this off an old tumble dryer or dishwasher, I can't remember, and they have a heating element in them, so they're the higher grade cable, thicker one. So I'll cut that, join those. Now I'm going to leave this single insulated, maybe in a box for the connections, not sure yet. And the reason for that is I can then use my AC current meter, and I can clip that around the wire and just see how much current it's drawing when I'm manually just cutting with the plasma, get a bit of a feel for that. And then the other thing I can do, I've got a little temperature sensor here, I can check how hot this wire is getting. I don't know, because I'm only going to be doing brief cuts, if it's going to mean much or get that warm, but it might give me a bit of a guide about what's going on before I work out exactly where I want to go on the electrics. Playing it safe, 6mm flex into a commando, but it's probably going to cost several £100, maybe more, to get the electrician in and get it all working properly. So not decided yet, but that's where I'm currently at. Okay, so I've just cut that off there, and I was in the process of joining it to this bit of flex here, because we've got the plug there. I thought that'd be good for a test, and we could put our meter around here and just measure the current. couple of things though. I forgot to mention this earlier. I don't know if you can see, but on that plug, it's a bit hard to read there. It's rated at 16 amps anyway. So again, doesn't really feel compatible with a 32 amp socket, and surely those pins are not good for 32 amps. So we're going to lose that anyway. So this was the other flex I was going to use, and this came off a dishwasher. She's got a heating element in it. It had a 13 amp fuse, so I thought, oh, it's probably got a pretty, you know, the cable outer looked pretty thick, but actually I've just had a look at the conductors and they're pretty thin. You compare those side by side, so this is 2.5, so that's probably 1.5, something like that. And you can even see, if you can see on camera, just how brown that copper is, and it's not a fluke, it's on the neutral as well. So I don't know, I'm not an expert on that kind of thing, but that looks like maybe that's got quite warm. So in the design of that appliance, they've down gauged those wires, still on 13 amp there, still pulling plenty of current, and does not look super happy. So anyway, we're going to abandon that. I'll put some tape over to make that kind of semi-safe. Obviously having a plug with bare wires is not a good idea, so we'll make that safe. We're going to get rid of that. It does mean though I can borrow the 13 amp fuse out of that, and I'm just going to wire this direct to there, put that in there. Again, I'm not super happy about doing this long term, but we're just going to put the current low and just see what happens and get some measurements. I think I trust this a little bit more than I have a few more amps perhaps in it than that one. Anyway, that's what we're going to do. Wire it up, measure it, and see what it does. All right, good for what am I doing? How are we going to get a clamp meter around that? Right, let's get some more coffee and I'll be back. Okay, I know it doesn't look great, and obviously it's not to code to have only single insulation, but this is just for a quick test, and it's all in the name of, at least in my view, added safety and understanding what's going on. So now we've got that exposed, I can bring in our little meter. Now I've used this quite a lot. Yeah, really quite like it. It's got it will do AC current reading. You could put voltage probes in the bottom of there. They come with it. Yeah, it's quite a nice handy little meter. So I guess we'll go on 20 amp range and we'll just check we're in AC mode. Yep. Alright, and now this is going to be up near the plug, so I'll have to work out how I'm going to film all this, but essentially that will go around the live, hang down like that, and we'll give it a go and see what we're drawing. Alright, so I've got a little thin test piece here, it's probably a millimetre or something like that, and I'll just use that as a guide, just so I can cut nice and straight, and we can index this along and cut various strips. Got my clamp on there, main plug in via the Euro plug there. Right, so we'll plug the air line in, switch on, and see what happens. As far as I can tell, I've done everything that they've said to do before, and then we'll have a look at the instructions and see what the options are. It's leaking. Oh, it's coming out the... It's coming out the filter. There's an air filter in here and there's a drain. I don't know if that's supposed to do that all the time. Or do you turn it or what? So we'll switch on and maybe there's a valve. I don't know. Let's switch it on and see what happens. back of the machine. Okay, I guess that's a good start. So we're drawing 20 milliamps, so not a lot. Air's still coming out of that drain. Okay, so if I remember, okay, yeah. So let's start top left then. I think from the instructions, again, I'm new to plasma cutting. You can release air out of the nozzle. That's right. I guess if you want to clear some stuff out of the way, or just check you've got air, or I guess you can manually cool the nozzle down. I don't know. Not sure that's useful. Or in cut mode. It's recogniser at 220, that's good. This is where you can cut plate or mesh. I think this is where it can hang on to the pilot arc a bit longer. Okay, mesh mode, plate mode, alright, we'll leave that for now. 2T40 will be like TIG cutting, so that'll be how you want your trigger to operate, but we're going to be CNC, so don't worry about that. And then I think that is, one is your post flow time, is it? Something like that. Oh, I'm going to have to look at the instructions, I can't quite remember. And, okay, I'll pressure it now. I think what you have to do is, turn on the gauge, you have a certain amperage and a certain pressure, but that is still leaking out, isn't it? Well, let's see if we can get this. Does this change? Oh wow, that's quite tight. Does that move? Whole thing's moving. Come back to that. And what we got here, I think that's our post flow time, isn't it? And we need to be, and then this is your amps. Okay. So we'll go around 20 amps for thin stuff, and so we need to be about 30 or 40 psi. So that is way too high. Let me turn that, whole thing's turning, isn't it? Ah, okay. Yes. Okay. So let's come down to 30. Oh, I guess what it's saying is for that amount of amps, you sort of in a good zone there. So if I put the amps up, does that change? Oh no, okay, no it doesn't. So it's just an absolute scale, so we'll stick it at 35. In the middle, and can't remember what those are. Hold on, look at the instructions, and then we'll see if we can sort that leak out. Yep, compressor's kicked on because we got that slow leak, but anyway, they are pilot arc, so I guess that's in seconds, and then the post flow time. So post time 3 seconds. We'll maybe bump that just to, oh, hang on, sorry. 4 just to cool the consumables down, and then PA 5 seconds. This will do, oh, I'll leave it at default 5. Feels like a long time that for the pilot, but anyway. Right, I think we're ready to cut. So you can see we've got the piece set up here. You can just about see the currents there, and you can see the display in the shot. So obviously my head will be down here, and I'll review the footage afterwards and see what I can determine. I also said I'd measure the temperature, so we'll give that a go. I don't know how reliable it's going to be on that wire, but let's take some initial readings anyway. 22.4. 22.4 is about what the ambient is in here. It's quite warm today. Right, let's give this a go. Never done this before, don't know what I'm doing. Let's see what happens. I think I went a bit quick, but it does work. Let's do that again and go a bit slower. And we'll check the footage and see how much current we drew. Wow. I was just hanging on by a thread back there. Okay, I just reviewed the footage and sorry, I don't know if you can hear me over that. The fans come in. And it was pulling about 13, maybe 14 amps, so you know that's really on the limit, isn't it? I forgot to measure the temperature, so let's see if we can measure any difference. About the same. I guess you'd really need to run it a bit longer and just build up some current and some time. Right, so obviously as you can see from that first cut, I've never done this before. I was going way too fast, wasn't I, looking at the footage? But I thought let's just get something through. I really wanted to not cut for too long, just in case something happened on the wiring. We are pulling 14 amps, which is I think too high in my view, so we'll have to deal with that. In terms of the cut, so that went on like that. So the kerf maybe 1-2 millimeters. It's all over the place because I was doing various speeds and I came back. Yeah, I'm not worried about that. In terms of sort of dross on the underside, a little bit where I started, not much down there, a little bit on there, and obviously because I'm against that straight edge, if I just ignore the slag at the bottom and just put it on the cut bit, yeah, nice and straight, or certainly within what you'd call straight for, or what I was expecting out of plasma anyway. Yeah, pleased with that. Okay, so in principle, good. Also need to brush up on my technique. So I think we need to look at that air leak out the bottom of the machine. I don't know why it's continually coming out of that filter. So let's have a look at that next. I've just turned it over so that the air filter's here and we're plugging in here. I can't quite see the connector. It's just there. And then this drain plug was here, and there's like a plastic shroud around it, and it looks like there's a valve up there. I just went to see if it'd rotate, and it's kind of sprung loaded back in, so maybe if we put some air on it, that will be okay. Now while I was down here, I noticed this as well. So you've got all your specs on there. So we're running 220, so it's max current, output 50 amps. Okay, notionally 100 volts, but I'm guessing that will vary depending on your distance. How many kilowatt amps that is as well. And then this is probably your input, isn't it? 29 in max, something like that. All right. Oh, there's a little schematic. Okay, so we've got AC coming in. I guess we might be dropping down there IGBTs into DC. I guess something like that. All right, that might be useful to someone. Just hook up the air and see if it's okay. Manual press up, release water with air. okay. Automatic release. Oh. Right, so what's going on? Built-in filter, yes. Manual press up release water with air. So I think, as you just saw, if you push it up, that's to drain it. You probably want to do that at the end. Automatic release water without air. Maybe, and water way out on bottom of the machine. Maybe it'll automatically drain every now and again by itself. But the point is, it is leaking air just slowly in. My compressor keeps kicking in. Let's strip this down, just see if maybe the sort of filter bowl is a bit loose and's got an air leak. Just tighten that up. I'll have a look. So let's get this cover off. And this should just slide off. Now come this far, we'll give you an overview in a minute of some of the main features, at least as I understand them, but for now we need to focus on this air filter down here. So obviously that's the drain system. I put it up on this piece of wood because potentially this can sort of stick out the bottom, but if you see, you've got the little seal there, O-ring, the valve stem, and then there's a spring that's holding it up, which means in a default position the air is going to leak round. You can pull that down, which will make it seal, no doubt. We'll try that in a minute. Either that spring is supposed to be on the underside to hold it down and then you push it up momentarily to release, or it's something I don't quite understand. Or maybe you're supposed to tighten this black bit. No, the whole thing's going round. So we'll hook up the air and I'll just pull that down, and if that seals it, well, I don't know. See if there's something I'm missing. Alright, well now we've got this far, this is something I was considering at the beginning, is you can kind of see we've got that, and I'm pretty sure that's a 1/4 inch NPT, so National Pipe Threads, that'd be the American standard. There's a screw there that holds that on, so you could take that off. They have put, you can't see from around there, there's like excess sealant all around there, sealing this to that. It's probably, they've put it on the thread and just wound it in from here, and it's just gone everywhere, so you'd have to clear all that up, but makes you think probably you could have a 1/4 inch NPT to a Euro male, if such a thing exists, and avoid spending like £85 on various adapters. So let's just take it from that. As you can see, there's a couple of changes, and same the other end. Anyway, we've bought it now, but that might help someone in the future. Anyway, for now we'll hook this up. I've got live air from the compressor, and we'll just see if that makes a difference. It's harder to get on because it's obviously I might do it the other way around. Yeah. I'll hook this up. Yeah. The airline is pulling it back. Right, try and keep that in shot. Try not to touch the electrical bits. Right, I've sussed what's going on. Not helped by the fact I've now taken the case off. So essentially, the airline comes in here. It's only got a single screw. It's on this plate, and it's kind of bent this way a bit, or the load is that way, and it's pushing that, and it means that black plastic is getting caught on the hole here. So if I push the whole thing forward, lean it forward like that, then it's clear of that hole and works every time. So I think when I put it back, maybe when I took it apart the first time, I did notice this kind of sprung back, so maybe I need to give it more forward pressure when I put that screw in, hold that plate in, and then that's nice and clear and all is well. All right. But while we're here, we'll give you a little guided tour. Okay, so there's a quick overview. You can see back panel there. It's got a power coming in, the switch. This is the pin to detect the arc voltage for the torch light controller, and then we got our 5-pin GX16 there for the CNC control, air in, and obviously a fan there, and you can probably just about see a heat sink. So all good at the back. Comes through for all the electronics and some pneumatics. We'll get into those in a minute. Display at the front, the controls, our air regulator, torch, Euro torch, and then the earth clamp there. So I guess we could start with the power, can't we? So it is coming in on 2.5mm gauge wire, so you know, it's a reasonable amp carrying capacity, but I think it's a bit marginal. Then we're on those display terminals on the switch, all good. They come into this board here, which looks like it's got relays on it and some power takeoffs. It's like a little motherboard. Another board back there, transformers on it. Also, you can see down there, there's little black things right at the bottom there. They're the IGBTs, so that's what's doing all the switching, I guess. And then you can see they get quite warm, so they're on that heat sink there. And then the other things, we've got the control board for the LCD display. We've got an air pressure regulator there. And then there's a little solenoid here, which, okay, yeah, because obviously it needs to turn that on and off. And then here, I know I haven't seen it in action here, but I know from some videos I watched this, it's got a detection for if the air pressure is missing or too low. So I guess it's teeing off the air pressure there. It goes into a little air pressure switch there, so it knows it's got good air pressure. That's probably all I'm going to say on the whole thing. The other thing you notice from electronics, being a CNC plasma machine, there's suppression and noise control everywhere. So we've got a nice healthy capacitor there. Got chokes around both those wires. That's the arc voltage, and then the other one is the control. And we've got a nice choke around there for the display. So just trying to keep that EMC under control. I don't know what else is really worth sharing. You can see some big heavy gauge wire for the earth and up to the main clamp here. And then this panel, here it is, yeah. This panel's got the big warning symbol. You can see some really big inductors down there. So I'm assuming there's some capacitors in here. So I'm not going to touch that, but basically I suspect that's what they are. And that's it, yeah. I'm not going to dive into the rest of the board because I don't know in detail what it's doing, but there we are. Someone might know a bit more than me, and that's what you've got there. Okay, I've just put it all back together. We've got live air pressure now. One thing I've noticed is you've just got to be careful there's not massive amounts of side load on this, because it's only on that thin bit of panel, and it basically moves where this ends up and it can catch on that hole. Now everything's bolted to this, so I'm not going to take it out and open up that hole, so I'll just have to think about that. But now you can manually drain it and it comes back, but as you can see, you just got to be a bit careful. It can move around a bit and get caught on there, and then it doesn't seal properly. Alright, other than that, so far so good. Alright, quick summary of where we're at then. So obviously we ran the machine and we were pulling 14 amps, even though we're only on one of the lowest settings, 20 amp output DC. I guess we're running about 110 volts for the cutting voltage. I don't know, we'd have to wire up the arc output over there and have a look at that. And I think we were set to about 30 psi and we're cutting 1mm, and yeah, once I got the speed right, that was cutting okay, so got a bit of a reference there. Overall, I'm very happy with the machine. The only thing, obviously, I think I messed up when I took it apart first time to check for feasibility of changing out the cable for something better, and I think I just caught the way that valve sits on there, but we fixed that and that's all fine. Right, so we're going to go on to like the CNC side of this now. I'm not going to go into too much detail because purposes I want to get this video out, get any feedback and learning from your guys' experience of doing this, just so I don't spend huge amounts of money in the wrong area before we get going. But I have bought some things, the bits I'm very confident about, so let's go through that now, and I'll tell you what my plan is. So there's obviously a few things you need software wise, hardware wise, to get all this working. Lots of different bits, lots of options, from super cheap to super expensive and everything in between. And I guess you got to decide on your own budget and risk when you buy cheaper stuff for interference or just having headaches with it. So this is my take on it all anyway. I got a nice industrial CAD package I've got access to, so that's no problem. I'll use that. I don't use Fusion 360 for the CAD. I just export IGES into there, and I do my G-code cam for my CNC machine, my CNC router, and that works fine. So I think I've seen that 360 does have a plasma tab tool, whatever, built in. I'm guessing that gives you pierce control and things like that are associated with plasma. I don't know. It looks like it does, but maybe it's basic. I don't know. But people have seemed to, well, I've seen people get that to work. So I'm going to go with that because I already got it. Sheet cam, I think it's about £120 for license, which I guess would do broadly the same thing, although this is dedicated, so I'm sure that's in some way better. But I'm going to start there and see how we get on. Any feedback on that appreciated. Obviously out of those you get the G code. Now I've bought some bits, and you got a free USB controller with that. If you click the box, well, it says free. It was about £3 or something. So I'm not expecting great things out of that. And it's designed to run with Mac 3, and there's a plug-in, and they've got some kind of link to a Mac 3 site, whether it's a pirate version, I don't know, or it's the limited lines version, not sure. I think I'm pretty sure I'm not even going to touch that. I'm just going to leave it in the box. It's kind of free. I've had really good service out of the AXBB unit from CNC, and I've got that on my CNC router and never looked back. It's never missed a beat. It's Ethernet controlled, and I know this is a blowback machine, but it is a bit electrically noisy. I think I'm going to shell out about the £200, whatever it is, for that and the license, and just go with that. Then I've got to run that on a PC. I know a lot of people use laptops and things like that. I'm tempted to have a look at these. I'm very interested if anyone's used these little Nook, or any you see these tiny little PCs like that, around the £90–100 mark. Just got Ethernet, a few USBs, and that would fit inside the control box. So quite like that idea. I guess they're fast enough. They've only got to put a few instructions out to the controller, and the controller then does a lot of the work. But don't know, any experience of using that type rather than a laptop appreciated. I don't really want to bring a laptop out here, to be honest, and it's a bit neat having it tucked away. Then we get on to the control side. So as you can see, I've bought some of those parts already. I'm sure you'll have your own opinion on what I've gone for here. I think I've built 4 CNC machines over many years, since probably about 2010. And lots of iterations in between, so I'm reasonably okay with this in terms of spec. So what I've gone for, I've got a power supply of 36 volts. Now I do have access to a 48 volt supply if I want to. So those of you who remember my drill press build, I've got a control cabinet with 48 volts in it. So and they're exactly the same size, so I could just swap them out if I need a little bit more voltage on the plasma. But I think I'd be okay with that. Going for some pretty standard 542. These are an old drive, but I've used those on various projects over the years, and I think for this application they'll be okay. Just like that. I'm sure you've seen those before. They can go up to 50 volts. So yeah, I'm sure you got your views on that, but for the price of what I paid for this, I'm okay with that. NEMA 23s, I've used those on lots of different machines and different things. Now I've gone for the slightly lower ones. You save a bit of money there. These are only 2 Newton meters, so if you're interested in the code, if I go in focus, it is there. Went for that option there. These are quite low inductance as well, so look like a pretty good spec. The other thing you can see in here, I've got a few spare rails that were on an old CNC machine that I built. So I've got 2 of these. One I used for the heat press insert machine for 3D printing. So I'll use this for the Z-axis because we're going to incorporate all the usual kind of features in there, so those will come in handy. And the other thing I've done here, I already had this 1204 ball screw ball nut. I just had a bit of a go at 3D printing a little adapter for that and press these bearings in, so pretty tight in there. I think that will be okay. There'll be a collar and nut in the usual way, and the couplers are on order. And I just used the heat inserts in the end in the plastic. And I think for plasma this will be okay. I wouldn't say this was stiff enough for a router or anything like that. You know, if you push this hard enough, there's a tiny bit of flex, but I think for this application it'll be fine. And then it bolts onto the machine. And as you can tell, I've already got into the CAD a little bit to get to that point. I do have quite a few of these. I'm not sure whether to use them or not. I mean, 3D printers, yeah. Plasma, 50-50. So I've got some of the proper like Oldham style couplers. Where you've got that kind of plastic or rubber material in the middle, so they're on order. I think that's it. A load of bearings that I've already got, and then one of these. I think that was my first attempt at the bearing holder on the floating side, and there was something wrong with it. I think I got the depth wrong or something, so I've just increase the depth, print another one. About 20 minutes or something like that on my Bamboo Labs printer. So these are PLA just to get it going. I've got some PETG as well. If I'm happy with the design, some of the more critical parts I'll probably print in PETG. Just a bit more higher temperature resistance and just a little bit more sort of industrial, I guess, or slightly more. We'll show you a quick look at the design in a minute. I've had a look at what's out there and I've decided the way I'm going to go. I think it suits my applications quite well for what I want to do. Linear rails will be a mix of 15 and 20. So 20 will be in the X and Y, and then 15 on the Z. Slightly overkill, you might argue, but I'm going to go for the kind of JD's Garage Langmuir basic system, basically where you've got the gantry sticking out on along like as a cantilever, and the main axis is back here. So you want to make sure that's well supported, and then the Z axis runs across there and it'll stick out this way. In fact, it means I can clearly get oversized sheets in there. You know, it's all, I think, is going to work out quite well. Obviously that gives you a limit to how far you want to come out here, but two 20mm rails with that axis running on there I think will be fine. I did notice that the JD's Garage design has got 3D printed kind of bearing carriers, and they do note heavily in their instructions that someone showed me that you need to make sure this is a low gauge gantry just for the weight and the creep and temperature creep and all that kind of stuff. So I'm going to avoid all that. 20mm rails, no nonsense, is going to be no issue with that, I'm pretty sure. And then ball screws, as you've seen, I've decided to go for on all axes. I'm very familiar with how ball screws work and the pros and cons of them. Wasn't that keen on rack and pinion or like a belt drive system. I think you could fiddle around with that retention and whatever. I like these, it will just work straight away, I'm sure. Right, so that's it on those. And then one more thing. So obviously you've seen I've got the rails in there. I've got they're both 15mm rails. So let's get on to some thoughts about the Z axis. So I'm pretty much decided on the torch height control. I'm probably going to go for the Proma system, which I think was about £120. I did think about making my own, sense it with the Arduino, filtering, run some code, click some relays on and off and feed that into the AXBB unit as a relay to inch the or move the head up and down slightly, basically to follow the contour of the metal. So the way that works, it looks at the voltage across the arc and it keeps that to whatever you tell it you want it to be, like 110, 100, whatever works. I don't know if that varies by thickness of material and all that, I don't know, got to get into that. But I decided sometimes it's probably just better to buy something that's ready to go, proven, and will work. I might end up spending half that or a bit more on parts and trying it out, and time, time as well. Also, you got to watch your isolation. You don't want to feed 110 volts into your controller, really, if you can help it. So I think I decided I'm going to go with that. In terms of touch off, I'm going to go with the floating Z design. So that's why I've got lots of rails. So the final part will be able to slide up and down. Will be a switch or a proximity for touch off. So it'll touch off the material and it will know the height above the material when it starts the pierce. And then I've seen that when you cut things out, sometimes they can kind of tip up and then the head could hit them and that might do some damage, and we don't want that. So I'm going to go with the breakaway feature as well. Not designed that yet, but probably some kind of magnets and an arrangement of 3 proximity sensors. I've seen that kind of design, looks okay. So if you hit something, it's a bit like a center finder, and it just pushes something out of the way and it breaks a contact on one of the 3 sensors, something like that. So probably going to go for those features on my Z-axis from day one. I've seen a lot of people build machines and then add those over time, so may as well put it in from the beginning and make sure I've got those nice features in. Okay, so I think at this point what I'll do is I'll share where I'm up to with the design. Some of it I'm happy with it, some of it's got loads of detail to go and kind of building my way through the system. So what I'm going to show you here is kind of going in point for now. Welcome any feedback, any comments, any thoughts on that design. So let's hop over to the CAD and we'll give you a tour of the status now. This is by no means finished, but kind of where I've got to.
Okay, so let's have a quick look at the CAD. Now this is just an early model, I'm still developing it, so I've still got some options in here and some things I haven't finished, but it gives you a bit of an idea about where I'm heading. So as you can see, it's kind of a cantilever style, so this axis here will stick out, and that'll allow me to put larger sheets and just make it a little bit easier, because this is going to live underneath kind of a cupboard area, and I'll just pull it out to use it. That's the plan. It'll all be on some kind of wheeled trolley. To give you a bit of an idea about what's going on there. This will be the control box over here. I haven't drawn the wheels yet and things like that. And then the blue box is 2 possible positions for the plasma. And then you get the idea, it's ball screws, rails, things like that. And then the cutting head is there. I haven't drawn the breakaway and all sorts of things on here. They're not on there yet, but give you a bit of an idea. And then the bed is the usual slats, and then I'm just going to 3D print some little spacers just to hold those in the right position. So that's my kind of thoughts. The yellow is just a sheet that shows the cutting area. So that's the kind of introduction and basic idea so far. Okay, so to give you a little bit more idea about how it's going to move and operate, we'll just slide this axis along here and you'll see everything move. So this will be the, I guess it's moving in the Y direction, isn't it? Because I'm going to stand at the front of the machine over here. And you can see, obviously the drag chain doesn't update and looks like the wires have come out, but gives you a bit of an idea. So all that will move along, and the idea is that that will sit into there, go in there, and then there's quite a big hole up there. This will be 3D printed, and all the wires will go through there, then come out into this cable guide. Here, be clipped in. You got up to 8. Fairly large cables, it's possible to clip in there, that should be plenty, and then it goes out to that drag train and so on. I'm still working on where to put the home or the limit sensor there. I haven't quite worked that out. Got a rail, Z-axis stepper, and then I have put the limit sensor and home one on this axis, and that picks up off that metal bracket there, and there's another one over at this end here, so that will be the home and the other one's the limit. Just a moment ago you saw I've 3D printed this part already, so I'm reasonably happy with that part of the design. Because this is all cantilevered off here, I'm going to use those rails, and I've got, this is 80 by 40 2mm wall, so I've got one here on top and then I've got another one underneath there, so that'll be nice and stiff. It'll be bolted together, and then they've got these spacers here. That should be a pretty stiff unit there. What else to show you? Let's have a look at the this axis along here. So this should, yeah, okay. So we can move it again. This doesn't update properly. Still got to finish off the ball nut. Obviously be connected to that, but yeah, you get the idea. That will move along there on those rails. Come to about there somewhere. I'm just working out where I'm going to put my limits. I might put something in here. Not quite sure yet. And then the other one is the Z-axis. So we can move either the whole thing or go up and down. So it will go down like that. Touch somewhere. Oh, it's gone off the edge, but touch on the surface, and then that should allow this. Oh, it doesn't work. Okay, got to set the limits up correctly. This allows this to come up and down. Then on here, I've also got to have a breakaway feature, just in case it collides with anything. But that's a kind of basic structure. Most of this is 8mm plate, generally, just really to get threads into it and things like that. Not that you need that much structure, but it makes that a little bit easier. And then these are 40 by 40, and I'll probably buy some standard hardware to join them, and then also machine up or plasma out maybe some joining plates in the usual way, just to get it all joined together. Some other thoughts are, I've got 2 positions for the plasma. I'd ideally like it over here, so all the high voltage stuff's over here, and then the control stuff's this end. The problem is I want to build like a downdraft kind of sheeting down here, cone shaped into a central, so there'll be like a metal bucket that will catch most of the sparks, but there'll be a bit of an air gap there. The idea is I'll have a big box fan and it will blow all the fumes here and the garage doors here, so it'll blow all the fumes out. Obviously if that's in the way, that's not going to be quite so successful, so I might have to live with it being here. With it being blowback style, hopefully that'll limit any of the EMI. Is a bit close, but this will be in a metal box. This is in a metal box, so we'll see how we go. And then that'll allow much cleaner air flow through there to get all the smoke out, things like that. So I think that's about it. You probably recognise this general format. I did have a look at the Langmuir system. I liked the idea of some of it, but I wanted to go a little bit stiffer, a little bit stronger. And I like the idea of the JD's garage machine as well, and it's got some of those principles built in. That's probably about it. Yeah, all the wires and everything will come into the box probably through a hole here. I don't know if I need to kind of EMC proof that hole with a duct and metal duct and anything like that. You'll also see I've got some of the drivers, power supply, the AXBB unit in there. There'll be a few other things. Torch height controller, I'm not decided. I may mount it on the front of the machine here, so the high voltage stays close and any interference, and then the signals from that go into the box. I think that's what I'm going to do. And I'll just make a bracket up to mount it onto here. I think that's my quick overview. So as I said at the beginning of this video, I've never done plasma before, I've just seen it on YouTube, and that few minutes ago when you saw me cutting, that was my very first attempt at plasma cutting. So if you've got any thoughts on the design, any experiences you've got, feel free to make those comments, or even link to some interesting videos you've seen. I may have seen them already because I've seen it quite a lot, but who knows, maybe there's something out there. And I think with that we'll call this video a wrap. Thank you very much for watching. It's a bit of a taster, a bit of a direction I'm heading, so I hope you enjoyed that. If you're interested to see how this video evolves, feel free to subscribe, click that bell icon in the usual way. And with that being said, see you next time.